computer to do these problems over here. It's remarkable that back then people were using paper and pencil, and they did have to employ people to do the computations, and they were brutal, by the way. So I'm glad we're kind of out of that realm. But they did a remarkable job. They really did. The book is quite good, all right? So what I'm going to do over here is the same thing I've always done, reset. I'm going to define my function. What's my function? X cubed. He loves the cubes, doesn't he? 2 star x squared minus 23 star x plus 70. Hit return. So the next thing I want to do is, getting a little better at it. I define this thing. This is the sixth problem I've done, right? So what's going to be diff, D-I-F-F, of f of x with respect to x. And then I'm going to define Newton's method. That's nx equals x minus f of x divided by df of x. And what I'm going to do now, plot, P-L-O-T. I'm going to plot f of x. And from prior experience, I know I probably should set bounds on this over here. And I want it between minus 5 and minus 6. So I'm going to say x min equals minus 6, and x max equals minus 5. Let's plot it out, see what we get. And I got something over here. And someone says, what are you seeing over there? Well, looking at it, it's between minus 5 and minus 5.2. And again, just roughly, any number you want to pick in between minus 5.2 and 5 is fine, actually. I'm going to pick maybe, let's see, minus 5.1. All right? You know what? Let's go a little more precise than that. Let's do x naught. Whoops, sorry about that. X naught to be minus 5 point, let's see, I'm going to say 1, 5. All right? Let's hit return. And now what we're going to do, we're going to get another guess, x1. All right, equals Newton's method evaluated at x naught. And I want to display x1. Certainly there's going to be a slight change, and there is. And so I want to do x2 now. What's x2 going to be? It's going to be nx1, and we're going to display x2 now. And what am I getting? Well, there has been a slight change, by the way. All right, so let's keep going. I'm going to do x3 now. And what's x3? Let's see, nx2, and we want to display x3. Let's see, yeah, there's a slight change. Let's keep going. x4, n, x3, and I'm going to put down x4 to display. Well, no change now. So what I want to do is just, let's close this out. Let's scroll down. And certainly we're getting the same thing. Now their initial guess was minus 5.1. My initial guess was minus 5.15. All right. It still took the same number of guesses, by the way. All right. So we got the same answer in the end, by the way. Remarkable. It's a great numerical technique. Still being taught today, but it's generally being taught today at the level of Calculus 1. Thank you.